Hello, everyone, and welcome to today's webinar. Today's webinar is a continuation in this series of webinars of what's new in SolidCAM 2021, and it is on mill-turn and Swiss type using the new tool table. The webinar will be given by Michael Vinetsky, the Vice President of SolidCAM and the product manager. But before we do start, Emil would like to say a few words. So Emil, you can go ahead.
Hello, everybody. Nice to see you again in one of our important webinars. Michael Vinetsky is going to show us in this webinar why we had to design a completely new tool table, because we want to be the leading software in mill-turn, advanced mill-turn, and Swiss type. And obviously, our existing tool table in SolidCAM 2020 cannot provide us with the definition of the tools that we need in order to support these advanced applications of mill-turn and Swiss type. So it took us about 3 years to really develop this new tool table. It was a big effort, combining definition by Michael Vinetsky and Alexander Miznyakov, and great programming by Ronen Shmatzion, and they really did an excellent job. And the result is something that no other CAM system today has. And Michael Vinetsky is going to show us now exactly why we had to do this new tool table for mill-turn and Swiss type. So, Michael, go ahead.
Okay, Emil, thank you very much. So, Micha, you can go ahead, and I will make you the presenter, and
okay,
you can start.
Thank you, Sydney. Okay, which screen are you seeing?
There, right now, I don't see any screen.
Second. It's always the issue.
There you go. Now I see your PowerPoint. Go ahead.
Your PowerPoint. How you switch screen to the second one? Give me 1 second to do it.
Okay.
Oh, it's much better. Yep. Now we
Okay.
see the screwdriver.
That's correct.
Yep. Okay. Thank you a lot for introduction. Thank you, Emil. Thank you, Sydney. I just want to use a moment and also say thanks for all our development team and our QA team, and special thanks for our resellers technical team and SolidCAM technical teams who give us valuable feedbacks about our developments, and you are best. Okay. So how Sydney said, we will talk today about Swiss type mill-turn in context of Toolkit. It's a name of the new tool table. So unfortunately I can't show everything what we did. It will take a little bit more time than we have, but I will try to show the major features what we developed and what we can show as power tools for the next versions. Okay, so let's start from simple things. The nose point definition. How you know in previous versions, the nose point was not completely free. It was only one radius on the cutter, and you had limited numbers of options to select the nose point. So I will switch to the card and show the example. Okay.
Hi. Okay. You could show your screen if you want, or is live there? Or is
Emily, you are online.
Okay, good. Okay, thanks.
Okay. So I'm going to see this tool. It's a nice tool. So today you can define any one of the cutting points, we call it nose points, what this cutter can support, but not only. You can also select any of radiuses of this particular tool. Of course, you will say it's not logical for this tool, but any one of the radiuses can be used. And for each one, you can go and define the cutting point what you want to use. Okay, and not only, okay, you can also override the values of selected cutting point, also the radius. So it's very important when you want to get in compensation, work with compensation with the cutter or with some special tools where you have more than one radius what can cut. But by default, you will get it with one nose point, but it can be usable for this by this tool. Okay, and you can select other. So this is one feature what we have in this point, and it's really, really important. When we go to the 3D tools, so how you pay attention, this tool is 3D shape. We automatically detect the corners of the cutter and give you the ability to select it. So it is also very important. So today, when you're cutting part and turning, you can get complete freedom of nose point definition. Is a huge change relative to previous versions. Let's go forward, and we will continue to talk about offsets and nose points. So today in a tool table, you can define what we call measure orientation. It's a particular orientation of the tool, how it was measured on machine. So if you're going to work with this kind of machine, a DMG Mori NTX machine, and you measure your tool with 45 degrees, you expect to use this tool only with 45 degrees angle, and you want to define special offset, what will show you and measure this particular nose point location. So I will also switch to the other machine, just show you how it works. So let's go to NTX machine. And go to the first job. And how you see, I'm using here 45 degrees tool. Okay. And once I select it from the tool table, okay, I can define how this tool will be oriented in the machine for this particular measurement position. So for each offset, I can say if it will be inclined only by physical axis, of course, by minus 45 degrees, flipped or no, and for each operation, you can use different nose point, and this nose point will by default use this orientation of the tool. So it saves a lot on measurement. When you build the tool table and you measure your tools, you can define everything in your tool table and not inside the operation. So also when you measure the tool, in this orientation, of course, the nose point orientation will be this nose point orientation will be relative to measured position, as in a real machine. Okay. So let's go forward. Some machines, same NTX machine or Integrex machine without B-axis contouring and other machines can use this turning tool only in this angle. So it means you cannot change the angle what you measured in machine and use other during the operation. You have to measure it again and define additional offset. This is a machine requirement. And for this type of machines, we have now additional option in the VMID. We call it inclined tool nose position. And when we enable it, this option, we are lock the tool orientation inside operation to only one possible by this nose measurement. Okay, so I will back to same part, and when I select this tool orientation, what I want to use in my job, okay, and a count operation, I see only one orientation is possible. Okay, it's very important because this particular machine, I can't just go and change the B angle and accept to use same nose point and same tool offset. I need to define additional one. So this feature allows you to manage the tool in Mazak machines, NTX machines, and others that require additional offset for any tool orientation. So it also reduces the number of mistakes of users. It's more clear as a tool table is represent real CAM part and much more powerful when you get in previous versions. Okay. So you can use this functionality. By default, you get it as no. So like in previous version, everything is open. But if you know your machine is not supported, you can go and define as yes, and you will get less mistakes during the operation definition. Okay. Also, to increase our support of Mazak machines and other machines, where we defined what we call index tables. So index table is like a table of tool indexes what the machines support. Why we need to define it and we cannot use what we get previously? Because on some machines, in this example of Interpolation machine, okay, if you will follow the letters on the index table, you will see the I letter and number 10 is just missing in this list. And you can find more cases like this in this list. So to define this table on the machine, it was defined with a lot of workarounds in post-processor. Now we can remove all workarounds and just define manually user-defined indexes for each tool and use it for each turret separately, or even for this station separate index table if your machine is required. Of course, you will see it's in a GUI and in other places, okay, where you want to see the index string, okay. So it's also reduce workarounds in post-processors and makes conversions from machine to machine more easy. I will show the example on the Integrax machine. When we are generally like to use this functionality, I will switch back to the screwdriver, okay, part, and we will see how it works. Okay. So I can go to my controller and I have a tool index table folder, and inside of it I have user-defined index table with not alphabetic order of letters as in a real machine. And once I can go to upper turret, station 1, I can see the same list on the tools. And of course, when you go to the operation, of course, or tool table, any place, okay, you will see the tool index is shown by same order and list. So I think it's really powerful tool, and happy we have it now. Okay. So let's move forward. Okay. Some machines, especially military machine, when you open the toolkit and you get this view. It's very useful and convenient for milling machines, but machines with rotary turret, linear turret, or combined turrets, it's not give a clear picture of what you have in machine, and you can switch to advanced mode. Okay, but today we have a setting in VMID what can open your tool table by default in advanced mode. So for military machines, Swiss type machine is very effective. You will get clear picture what happened on your machine. And I just want to see why we need a advanced mode machine. This machine opened with simple view of tool table. So I see the magazine, tools what related to B-axis, and lower turret tools, list and offsets, everything is perfect. But here, for example, for the lower turret, okay, it's not such clear for me what's happened on my lower turret. So I always need to move here and see what's going on, okay? But if I switch to the advanced view, I can see the clear picture what's going on my lower turret. I can move tools from turret to turret, easy, okay? I can see which station is from station to station, sorry. I can see which station is empty now, what's not used. And also, what's very important, and I see my magazine, how many tools is in a magazine now, and how many tools in the station now. If I go to my tool on the spindle magazine, so I see here some strange tool. And if I want to put other tool, I need to select it and mount to the upper turret, and I will see it. Okay, it's like a manual working with tool changer and tool magazine is behave like a real machine. Is maybe too detailed is it for 2.5 user and 3-axis machine user, but for mill-town machines, it can be really important to see how it behave in a real machine. Okay. So I really recommend for mill-town machine, use the advanced mode as default. It will give to the customer more clear picture of what's happening inside. Okay, so I will not save it. Get back to my presentation. Okay, so we see in the advanced mode machine, and let's go forward. Okay, the tool is changed between stations. It's become really easy. I just want to show one case where we need this functionality. I'll go to the other part. Okay, and let's see how we can get a problem with this part. Okay. So I have a simple part here. Okay. And this part is working with rotary axis machine. Let's calculate the jobs. And let's see only a few first jobs, how it looks like in simulation. Okay, I will just go here because now I know where is the problem, and let's see how it's going on. Okay. So I will go to the default view, and we see here very powerful. All turrets are in position, turret is shown. And what I'm going to see now is why we need this view. Okay, you see here in this position, in this operation, I get a collision with neighbor tool. This tool is completely not used by operation. It is not a pair when we design the operation. We see it now, and I get a collision. So the natural solution for it will be, let's exchange the tool in station number 8 to station number 6. Let's just exchange them. So I can go to the tool table, wrong button. I see it in this view. I'm just go to tool number 6. Here is it. And say him, just exchange me with tool number 8. Done. And just save the operation. Go again to same job where we have the collision. I think it's here. And now there is no collision anymore. This operation, yeah. I get same phase grooving, but this tool is not collide the fixture anymore. I can do it even without going to machine simulation. So you see it load very fast. You see a huge models of cutters and inserts and fixtures and model here, target itself is appear in simulations. Work very fast. It's not give you the kinematic solution of simulation, but for first collision checking is very powerful, and you can go to the tool table and by simple exchanging the station to get the perfect setup for your machine. Okay, I'll back to presentation. Of course, it's one of the reasons also why it's better to use advanced view, because you see exactly which tool now on station number 8 and everything is in front of your eyes and you can do it safely. Okay, additional improvement what we did, it's not related to tool table himself, but it's very powerful and I wanted to show it. It's just one small button what we added in machine preview. Here near the Mac coordinate system, we have now the position coordinate system. And I want to show how it works like. And just go to other part, same what we've seen in the presentation. And this coordinate system and why is important for the customer, especially on machines with complex kinematics. Okay, so this particular machine is B-axis machine, not such complex, but I'm making a groove operation. It's not groove like a pocket slot operation, don't know. Here on it, and I'm using my position here. So far we know when we're working with post machines, okay, we cannot see the X and Y orientation of his position. So if you want to examine your G-code, sometimes it's really hard to understand where the start point will be. I know it will be somewhere in Z positive, but I don't know which coordinate and X, Y I should get here, even approximately. And it's giving me some information, but not enough. But if you go to machine preview and you press this button, you will see now also X and Y orientation. And what it says me, this is a real orientation of your position, what you will get on the machine after the plane rotation command. And it's very important because also in G-code, you will get this point, the start of the toolpath, relative to the same coordinate system. So here I can see it will be like close to the 0 and Y and some big X and smaller Y, Z also positive. So I can examine my G-code very easy and understand if I didn't make some mistake and be sure my G-code is proper and everything is correct. I also can understand how I will see my coordinates on machine when I make a setup. So it's small button, but it gives you such big functionality, and I really recommend to use it when you examine your compound. Okay, so let's back to the SolidCAM. Okay, so how it's said is very important. Is the same coordinate system what you get for G-code, exactly same. Okay, additional improvement what we did is a machine simulation. As a machine simulation of Milltown machines with a lot of stations, and especially when you have a lot of indexes for each station, it's become huge. It's very big XML file, and it's also affects the loading of machine simulation time. So in 2021, you can remove the size of XML from all these huge, and we get in the station 2 here, and here I just have all stations in one, to remove everything except of the stations, okay, and also all TH adapters in magazine, and it will reduce the size of XML file and make the loading of your simulation much faster, okay. I just want to show you the example of loading of machine simulation in 2021 on this part. Okay. So it's loading. Yeah, you see. It's pretty fast. Still, it's not take too much time. And now from this point, when we get it's loaded, it takes a few seconds, but at the end, it's much, much faster than we have in previous version that is done. Okay. And when you go to this simulation, okay, you see the amount of the holders here is huge. And the resolution of the holders is really fine. So it's big models. And some of them are contain few models and few cutters. And you can run it, of course, in simulation and see how it works today. Okay. So what we can see here in this simulation is a very simple thing. Okay. First, why my holders are blue? I don't like this color. I want to change it to green. Okay, and if you want to do it in previous version, you must need to edit the machine simulation file. Okay, so how are you doing it today? Let's go to our to our simulation and see in Toolkit we have a setting option. I will show where is it. And in this setting, you can change the colors of your cutter, arbor, holder, shank, and fixture. Okay, so once I go to the Toolkit, and I can go to the setting, here's my place of changing of colors. I don't need to go to the machine simulation and change colors. And what is more important for us, you will see the same color of holders in both machine simulation and machine preview. So each component type will show with same color, so it's much more easy to understand what you're doing on the machine and compare the machine simulation and machine preview and understand your CAM part more clearly. Okay, so here is a place you can do it by just let's change this blue color. I really don't like how it's appear, and we will make it not this one, same as the picture. Make it, yeah, this one is better. Different blue. Okay, I have to save and exit. I have to reload my tool table second time to see the colors changing. And yeah, this is a different blue color, more likely for me. Okay, so let's go ahead. You've seen also in my part of my present simulation, when you see all the tools are mounted on the are shown in the simulation. Okay, so this kind of functionality, I will back to it and show it again. Okay, if I work with flower turret, for example, and I go to SolidCAM simulator, okay, you will see all tools are fair. Okay, it's much better to detect collisions to see how space I have to make an operation, but it's still a beta version. So to manage this better visibility or better functionality, we added to SolidCAM a new setting. So if I go here to SolidCAM settings, okay, let's let it open. Okay, I can go to miscellaneous and beta option. Here we can find, okay, not only related to simulation option, everything what we will add for beta verification, you will get can enable and disable here. Okay, it's and you know if you're using it, it's sometimes not work stable, sometimes it's maybe colors are not clear or something shows wrong, but okay, it's beta and we need to run it somehow. And also, if you have some feedbacks, ideas, we will happy to hear it. Okay, it means today we have an option inside settings to enable some beta functionality and disable it if you don't want it. Okay. Of course, if you disabled it, you will see as it's in this situation only one tool shown. Okay, maybe it's for users who don't have a PC, what can be, some quadro video cards or something like this, is better to not enable it because it's you need pretty fast PC to see it very fluently. But if you don't have it, you can continue to work by regular way and show only one holder, one cutter, and it will be faster to load the tools and everything. Okay. I will back to demonstration. Yeah. So today we support also self-index turrets. Okay, and I will show an example how it works like. So I will also switch to machine. I'm going to US machine. This machine is have a rotary turret with 12 stations, and I also have like a half index station, so you can define 24 stations for the machine, whereas the additional 12 station is like a substation, is not a real station, but it can be indexed to this position. How it looks like? So let's open the machine preview, and I will hide my machine just to see only the tools. And here you see this holder have like a main tool and also additional tool what shifted 15 degrees. Same we have for this milling holder, okay, and for this milling holder. I have like a main tool and additional one shifted in 15 degrees from my main tool. How we manage it in SolidCAM? I just go to the tool number one, okay, tool item number one, and what we see here, I define special holder, what can hold two tools, and second tool, this one, is inclined by 15 degrees. And how I'm managing with 15 degrees is really easy. I'm going to cutting point, I have my measure orientation, I said this tool work an additional angle of minus 15 degrees from my main tool. Okay, and once I will use this tool in my operation, okay, this operation is used my tool with 15 degrees, you will see also the tool is rotated for 15 degrees, okay, and we can cut with it also. You will get an G code and everything is really simple, but you should know the exact angle what you have to switch and use it, of course. Okay. So to enable this functionality in VMID, okay, you need to go to your rotary turret. It can be enabled only in rotary turret and options, and we have this here. Okay, rotary turret interpolation by default is no. If you want to use this functionality, you need to switch to yes. It's also reduced the number of stations in VMID because previously to make this machine, we was defining 24 stations, real ones, okay, on the machine, and playing with it and each station can have also many letters, and you will get a huge amount of items and components in your XML file and machine simulation, and your VMID become bigger and it works slower. Here is very simple. If I go to my VMID, nothing special, only 12 stations, and it works. Okay. Same about the machine simulation. I go to my machine simulation. I will see I don't have special functionality inside to support it. Everything is done. Okay. Here's my stations, nothing special. See, the XML is pretty short. Only the 3D models, 12 stations, target stock sets, feature sets, everything is done. So, of course, when it's smaller, it works faster. So here was a half index turret. Okay, of course, to simulate turning operations, and we was used to run the turning simulation. And in turning simulation was huge missing feature is how we do simulate cutters with STL holders. Okay, so today, when you simulate cutter with STL holder, you have like a projection of your holder, and you can verify the collisions what can happen with your target. Okay. In previous version, you was seen only the insert. Okay, for STL holders. So today is much more powerful, but sometimes, and I will show you an example, okay, of this phase groove tool. This collision, what you will see, okay, is not real. You see it. Why is not real? Because if to understand what happened here, you cannot do it in 2D. So I'm just will switch to Solid Verify, and now you see there is no collision here. I have my special tool what's designed for this kind of working and is not collide the material. So it's called like a false collision, and to avoid it today we have in the tool, yep, this holder protection feature. feature. If you don't want to get this collision, you can just unselect the holder protection and you will get the tool path that skips the collision with holders. For face groove, internal turning tools sometimes, and also for some special tools, you cannot use 2D collision protection, so you can cancel it if you don't have a good tool path what you want to get. So it's also an additional feature for the turning. And of course, if you want to simulate your tool path in new simulation, okay, I think it's a really powerful tool. We have a special mode designed for the turning, and in this mode, you see your target, stock, updated stock, and you can run a simulation, of course. Okay. And of course, you can stop it and even pick on the tool path to see where is your tool, how it looks like on this particular point, if you have any collision here. A really powerful tool. I really like it. Okay. It shows you like a old style geometry, but it's very informative. Okay. Okay. So this kind of improvements what we have in simulation is, I think it's give you a lot of information, and also how you can see you have a multi-cutter here, and you can see the balance graph working here, everything for interning, and also it's use 3D models shadows. Okay, so let's go forward. Okay, till now I talk about mainly regular mill-turn B-axis machines, things like this. What about the Swiss type? So in Swiss type is a huge improvement in the modular working. So how you see here, this machine, this Tornus machine, it really looks like a Lego. You can assemble any holder almost in any place, mix it, and it works on the machine. So how you manage it properly in SolidCAM and Toolkit? Let's go and open some machine like this. Okay, I open the Tornus machine. What I have here, I think it's, yeah. Not about the machine himself. Okay, it's a special provision. I will talk about the toolkit. Okay, how I manage this huge amount of tools and special devices on simple machine. So yeah, here is my machine. Okay, looks like complete disaster. Okay, and what you see here, okay, sorry, here these folders, I will pick it just to highlight it. Okay, it's like a Lego holders what you can assemble in these connection points where I call it PF. Okay, and for each holder can contain also few tools and additional holders, subholders on it, everything. But also you can in machine go and remove all these holders here. Okay, and instead of it, let's go to my storage. Okay, put this nice holder. It's such easy to do it, and it's such powerful. And I think it also looks amazing. And also you can imagine how many work you will save to define different configurations on this same machine in VMID. I will show you how it looks like. Here's same machine defined in 2020. You see, I even don't want to count how many submachines we have here and how many turrets to emulate this type of holder. And also, I'm not sure if it do support everything. And the go to 2021, that's what you have instead of all of it. And the number of submachines, what really explain you the machine, is here. So this one to this one. So your machine simulation is going to be smaller, your VMID is smaller, the number of options is going down. Much more easy for customer to configure a machine. You can define setups, everything, And here is it. It's 2021. Okay, I will back and just save it. I'll go without save it. Okay. So additional feature what is required by citizen machines, it have a lot of holders what have like Indexial axis. This axis what you need to open the screw, set the angle and close the screw. It's not something automatically, you need to do it manually. And how you do manage it? So, of course, in previous versions, we was defined like a virtual axis, not real one, like a B, and starting to play with it. It's never going well, it's always workarounds. So I will go to citizen machine, what configured for 2021. Let's go to the toolkit. Here is machine. Okay. And special thanks to Daniel. He's did this perfect machine simulation. And special thanks for Dima for previous one. And what I see here, I have this nice holder. Okay. But it's not simultaneous. This holder is the axis holder. Okay. It holds a lot of tools. Okay, I see one, maybe 11 tools under one holder, but it also can be rotated around this axis. But it's not kinematic axis. But I can go and set the value. From this point, I'm ready to make a CAM part. Any of these tools can be used, of course, in particular orientation. Okay, so but you cannot change it simultaneously. Okay, it's not simultaneous axis. And of course, you can disassemble this holder and put another and do the same. So this ability to play with holders and make like different kinds of assemblies is really, really powerful. I also want to show something small on this machine regarding the measurement of the turning tools. So if you're familiar with this type, you know the tool is, for citizen, for example, is this kind of tool. It should be out 20 millimeter from the holder. Okay, it's not a precise 20 millimeter, but it's like a reference point. It means if you out of holder 20 millimeter, it's a zero. So how you manage it in SolidCAM today? And go to this tool, and you see here's my reference point, but I am not relative to zero, on the zero, okay? And how I know what's the distance from here to here? How I can change it? So I can go to the holder of this tool, because it's this what I want to move, okay? Go to mounting here, and I can just reset to the nose point. If I want to change the position of the nose point relative to this reference point, I'm just going here and go and change the position relative to nose point. It's a 2 millimeter. Okay, it's exactly how it looks like in a machine, and you can go and send these values to the machine and set the tools. Okay, and also for customer is very clear because it's what he see in the tool table on the machine. So it's also simple but very powerful functionality. Okay, it's I'm showing it here so you can see how we can move tool from any position by resetting position tooltip to required position. Really easy. Okay. Of course, the major functionality what was missing in previous version is the support of mini or STL turning tools. So I'm really happy to present you how it looks like in SolidCAM 2021. Okay. I go to this part. No, I'll go to other part, and I prepared the tool. Let's go to the toolkit, and what you see here, the tool completely defined from 3D model, okay, with the cutter, with the shank, and everything it's shown perfectly. You can work with this tool. Of course, we will make additional webinars when we will explain how to design the tool, how to export, import, how to use it, and which functionality we do support, and which one is still not. But this tool already can be used by SolidCAM to make a trapezical thread, if for this particular case, yeah, and can be mounted on the machine. Okay. Of course, because we support now the 3D tools. It's been designed by STL cutters. Okay, we can support. We can support now the special shape tools. So you can design your tool as you want, export it to 3D model, and define as STL or STP cutter. And I will show how it was done other part. Yeah, this one. And you can cut with this tool and get the shape by one cut. So in a lot of factories I've seen this feature. Okay, so you can see here's my tool. Yep, and it's designed from some 3D model. I can go and simulate it. SolidCAM simulator. Here we go. One cut, full profile. This tool designed by SolidWorks. Everybody knows how to do it. You just copy the file, define 3D model, and it takes a few minutes to design it, but the time while you're saving here is huge. Additional functionality what we also added today to support the 3D tools is skipping the limit of cutter angles. It's a little bit hard to explain what it's doing, but I will try. Okay. So once we go to this operation, what I want to cut some, let's go here, I believe not this operation, to the handle, yeah. I want to cut this profile with SolidCAM. Sometimes the limitation of angles, what was designed to support simple tools, it's in previous version, and simple tools mean only one arc and two lines, simple tool, was not allow us to get to some particular places. How you see here, it's just block me from entry to this shape. Okay, and this tool, general, is do support it as well. Yeah, it's defined by 3D model, but in general, it can go here. Okay, but it's blocked me. And you meet a lot if you're working with turning, with cases, and SolidCAM, previous version. So today, when you're using 3D tool, I can just skip all limits and go and say the complete freedom. And the tool will go everywhere where it can go physically by the shape. Okay, so here you can see how it works now today. Okay, so with 3D tool, I can get the full profile of this screwdriver. Okay. So I also recommend to play with this function. Okay, you will easily recognize what it's doing, and also to try to define cutters. I believe it's for big number of customers. It will be very effective solution for simple parts or mass production parts. Okay, at the end of my presentation, I want to say a few words with not main subject of Milltown, but you cannot say Milltown and don't say GPP. Okay, so in GPP we have a number of improvements. Okay, so first is arc execution in any machine plane. So I know it was supported partly in previous versions, so today is completely full support. You can get arcs in any machine plane, depend of your tool orientation, and or tilt plane. You will automatically split arcs to lines if the machine don't have a plane for your work, for your arc, of course, and it save a lot of work from the customer and also much more safety. When it was before, the G-code generation became up to 25 times faster than previous version. Okay, it's working very, very fast. Okay, we designed special effective testing utility and to make our trace output with 0 bugs. Okay, so today's target, no bugs in G-code. Not one per month, not one per year, 0. And this smart effective utility make it with testing our output constantly, every day. And each bug what can appear, we will automatically found it and fix it. Okay. Of course, what I showed in machine preview is a visual verification of result coordinate system. It's help a lot for you to understand what the G-code what you're going to get and to make a setup on machine and understand what you expect to see in machine movements or machine screen. Okay. Today we added the support of dynamic offset for the pose set. So people who are dealing with table machines know what I talk about. So in previous versions, the pose set for table machines wasn't support dynamic work offsetting. Today is do. We have support of double coordinate system rotation. It's mainly used for tombstone machines. Okay, when you want to rotate your coordinate system twice till you get to position. Okay, I think we will make a webinar about these functionalities. Okay, we have a huge collection of new get functions. So for GPP writers is good news because what you can do in one row, you can do sometimes in 20, so it's reduce the post working. And of course, Simco editor become our official NC editor, and it will be come with our next installations. Okay, so I think it's good news for customers who want to see like a coloring in G-code or stuff like this, or maybe some templates what he have in Simco, what can do in Simco. So easy stuff, what can help a lot for customer. Okay. So thank you very much. We finished here. Okay, and
Okay, Michael, I see that there are just 2 questions for you. So if you want to take a
yes,
look.
I see only one. Okay, just see. Okay. I cannot see. Can you read the questions? I can't see it on my screen.
Sure, no problem. Hi, Michael, very nice features. If I understood you properly, the turret with magazine has been shown in Toolkit just only to see how the tool will be mounted in the turret. All the tools for this turret should be defined in magazine of that turret.
Okay, it's a good question. I will show an example. The example is pretty easy. I think this Integrex machine is exactly what we are talking about. Okay, so once you go to the machine, I have a tool magazine. This tool magazine, particular one, can hold 99 tools. I'm not sure if it's true, but let's say, and it can share these tools with turret number 1. We call it upper turret. Okay, so this is the configuration of the magazine. It's random pocket magazine, 99 pockets, and serve the upper turret. So when we understand this definition of magazine, I can go to Toolkit and see what we have here. In the magazine, and now I'm in a simple view, okay, it's very important, okay. I have a number of tools, okay, and when I'm in simple view, once I click on the tool, it's immediately appear in the station of the spindle, okay. So you don't need to deal here too much with moving tool to turret or back, okay. Everything what I selected is immediately appear on the turret. For lower turret, once I select the tool, it's indexed because it's a rotary turret to the position. So you see, I select tool number 2, it's indexed. Tool number 4 is indexed. So this is the main difference between turrets, how it behaves. For spindle turret, it's just assembly the tool. For rotary and linear turret is indexed to position. But once I go to advanced view, okay, I see a little bit different behavior. Why? Because you see now the tool is mounted on the turret. Which tool? This one. Okay, what I see in the upper tab. Once I select other tool is not directly mounted on the turret. I can go here and say, put me on the turret. I can go here and say, put me on the turret. And it will exchange it, but you have to do it manually. It means if I want to see my tool on the turret, I have to go here, upper turret station, and I will see it's manually mounted on the turret. I'm just emulate the tool change operation. Tool was on the turret, go to the magazine, and this one is going to the turret. Okay. So this is the main difference also between a simple view and advanced view. If you work in a simple view, you don't need to do it manually. Once you pick it, it's automatically mounted. In advanced view, it's like more manual working, more precise. You can control everything what happened on the machine. Okay. I hope I answered the question. Thanks.
Okay, there's just one more quick question. Do you have to update? Do you have to update the old machine simulation, or is it going to work automatically with the new version of 2021?
I just missed I missed to say it about it. I think I wrote it, but I didn't say it. And yeah, it's very important point. Any machine what works in 2020, 2019 on earlier versions will work in new SolidCAM 2021. There is no limitation. But if you want it to work faster, you need to make a makeup. Okay? It's not, you don't need to convert your machine. We are not converting XML file. Okay? It means you have your old machine simulation, you can run it, everything will work. You will not see any difference in the visualization. Maybe loading is a little bit slower than new, okay? Because, okay. But if you want to make it faster, I mean faster than previous version, you need to make up it. So if you customer, go to the support and ask to make up your machine. If you are a reseller and technical team, so we will make a webinar about it, what can be changed, what is not changed. It's very easy. It takes 5 minutes just to remove what you need, what you don't need. Okay. But again, old machines are working, no problem with it. Any old machine will open and work as previously. Okay.
Okay, Michal, thank you very much. Before everyone, Emil would like to say one more thing. Emil, I will make you the presenter. And unmute yourself and talk.
Hello, everybody. The last thing that Michael Vinetsky mentioned, we assure you that SolidCAM 2021 have complete compatibility with SolidCAM 2020, 2019 versions. The tool table is converted, okay, the machine simulations. So this is something that we spend a lot of time on to make sure that the transition from previous version to SolidCAM 2021 is the most smooth possible. Now, some comments about what you have seen. I'm sure that you all agree that what you have seen in Michael's webinar is truly amazing. The powerful combination of our new tool table and the new SolidCAM simulator for mill turn and switch type applications is absolutely unbeatable. I could guarantee you that no other competitor CAM system has any tool table or simulation functionality that can approach what you have seen. Therefore, make sure to use SolidCAM 2021 in all your upcoming potential customer demonstrations. They will be amazed and will be strongly motivated to take a positive decision for buying SolidCAM 2021. Now I want to add two more things. First, you remember that we have launched the SolidCAM forum, and it's already having so many members and so many people posting there. So make sure that you become a member of the forum, watch it every other day, see what are new things being posted there, and obviously we'll be very happy to see your own posts in the forum. I have mentioned several times, but you have to do it and watch it, and then you'll understand the value it will give you in marketing, sales, and technical information. The last thing I want to mention, I'm sure all of you have heard already about our SolidCAM World 2021 virtual summit. It will be on April 6 and 7 in nearly 3 weeks. It will be an amazing event. Each day will be about 5 hours, and I will show you very quickly the agenda. Just go through it very quickly. So you'll get information about SolidCAM 2021, its highlights, and the amazing new tool table. We will talk about how we manage competition in the German market. We'll give you a good idea how to beat the same competition in your markets. We will talk how you do successful selling of SolidCAM's switch type solution, the power of 3D milling in SolidCAM 2021, an invited lecture, very nice one, end of vaccination. We will give you competitive info, SolidCAM versus Esprit. It will be given by a new employee of SolidCAM who worked 10 years with Esprit, and now he learned SolidCAM and he knows what he's talking about. And we will show you again, if you have not seen it before, the new SolidCAM shop floor editor and shop floor simulator products. In the second day, we'll talk about simultaneous 5-axis in 2021, an update about our eye machining technology, how we do sales and support online in SolidCAM USA, our partnering with machine tool resellers and tool resellers worldwide. We'll talk, Marina Vilkina will talk about the power of advanced mill turn and switch type in SolidCAM 2021, and Daniel will discuss switch type post-processor development and availability. Also, we'll get one of our staff in the US to talk about how is the best way to turn a technical machining person into a switch type expert. Many of you need to do that to be able to sell and support the important switch type solution. We'll have an event about best SolidCAM resellers of the year, and Tekias, as our biggest reseller worldwide, will be talking about how they achieved their great results. And the final lecture will be a sneak peek into SolidCAM 2022. We call it the future of CAM. You'll see amazing things that we are working on and we are planning for SolidCAM 2022. So make sure that you register for this event, and also make sure to get your customers, partners, potential customers to register. You just can press on this button, register today, in the invitation, and you'll get to register for the event, and you will get your own username and password, and then later you could log in during the event on April 6th and 7th. So register today and I will assure you you'll enjoy this amazing event. Thank you very much, and see you again in next webinar.
All right, thank you very much, Emil, and I hope everyone enjoyed the webinar. And again, of course, thank you very much to Michael Vinetsky for giving the webinar. Take care, everyone, and have a great weekend. Bye-bye.
Bye-bye. Thank you, everybody.